So here we are, 4.7. We talk about trig function, in particular sine. Sine of 30 was 1/2, or sine of pi over 6 is 1/2, opposite over hypotenuse. Remember that. So now, if we want kind of to move this to the other side, we would say that the sine inverse of 1/2 is pi over 6. In other words, when you talk about sine inverse of something, you're asking yourself, what angle do you know has an opposite of 1 and a hypotenuse of 2? So we go back and remember and recall that 30 degrees, its opposite was 1 and its hypotenuse is 2. So inverse sine or sine inverse. So you usually have the sine inverse sine, sine to the -1 sine, or you can write it out as it's inverse sine or sine inverse, how you want to think of it. Now sine inverse of x is the angle whose sine is x. So sine inverse of 3/2, square root of 3 over 2, for instance. What angle has an opposite of square root of 3 and a hypotenuse of 2? Remember from the first material leading up to the first test, that was 60, or pi over 3. So now we're going back in terms of radians. So the problem is many angles have a sine of square root of 3 over 2. So how do we know which one we seek here? So if you do this, now if you go and you say, well, sine of 60, say maybe somewhere here, is a square root of 3 over 2. But later on, sine of 240, I'm sorry, sine of 120 also had the same answer. So this could also be 120 degrees, or 2 pi over 3. Or essentially, it could be even bigger than that. So the problem is there's many answers that could give you sine inverse of square root of 3 over 2. Because just remember, when you went on a circle, 120 also worked. Also, 180 could work, or 390 or 420 could work. So there's a lot of different angles that can give you the answer. The problem is when you graph sine, you talk about inverse function. It has to be a 1-to-1 function for it to have an inverse. It has to pass the horizontal line test. So notice that sine goes forever this way as a wave. So it will not pass the 1-to-1 test. It won't pass the horizontal line test, so it's not invertible. But we can restrict this domain. So here's how we fix the problem. We say, well, look, there's a problem here as it goes through all of this. It's going to fail. But if we just cut this part out, just look at this part, that would be 1-to-1 or invertible. So we restrict the domain to go from -90 to +90, or negative power 2 to power 2. That's what I'm doing here. So if we keep sine, if we restrict it to negative power 2 to power 2 as far as its domain, this part will be invertible. So it means over here, the answer, when you look for sine inverse, the answer can't live past 90 or past -90 on the left. It has to be between 0 and -90 and +90. So the only answer that will fit this is 60, or pi over 3. So they're not going to have more than one answer because we're going to restrict it. Now later on, we're going to loosen that restriction because we're going to solve an equation, and we're going to look for all the answers that kind of fit that equation. But for invertible, we restrict the domain to go from negative power to the power. So again, like I said here, it's invertible. So sine inverse, when you find a sine inverse of something, the angle itself cannot be less than negative power 2, not greater than power 2. It has to live within the, or what we call it, range. It has to live within those values. So when you take the sine inverse of this, you actually take a diagonal here. You put a line right through these 2 points like this, and a line through these 2 points right here. So under this line, if I may, this thing will flip over that little imaginary line there. Kind of look like this. Over the line, it will flip under the line. Kind of look like this. Now the x values will be the y values now. That was actually inverse. X becomes y, y becomes x. Notice the y-axis, the values become now the x-axis. So the values become the x-axis. The angles become the y-axis. Here are the angles, they become the y-axis. If we take sine inverse of these numbers, the answer has to be an angle. But notice that you can't go past 1 or -1. So to get the sine inverse of something, you can never take the sine inverse of anything sine inverse of x is only defined when x lives between 1 and negative 1 and 1. In other words, you can't take the sine inverse of 2. You can't take the sine inverse of 3. You can only take the sine inverse of numbers that live between negative 1 and 1. The answers, the y values, the answers to this, sine inverse of x, its answer itself cannot be bigger than 90 and less than negative 90 within the realm of this inverse stuff. Cosine inverse is very similar. We break the part down from 0 to pi because if you continue it, it will fail to be 1 to 1. So we take this part and we kind of flip it on itself diagonally. So this part here kind of comes upward. This part here goes downward. So this part shifts down. This part kind of shifts down. That part shifts up. So it kind of flips up on itself. This little part kind of, which is down here, normally flips up about over here. This part, which is down here, flips on itself here, kind of goes in this fashion. So it kind of works out this way. This is the inverse function for cosine. So notice that the cosine inverse, also cosine inverse, is only defined when x lives between negative 1 and 1. In other words, you can't find the cosine inverse of 2. You can't find the cosine inverse of 3. You find the cosine inverse of negative 5. It has to be between negative 1 and 1. In other words, the numbers that you plug in when you're trying to find the cosine inverse of something, that something has to live between negative 1 and 1. Now, the answer can only live between 0 and 180. So when you take the cosine inverse of a number, you can only get an answer between 0 and 180. So notice that here, these are positive. So if you take the cosine inverse of 1/2, the answer is 60, somewhere here, somewhere right there. Now if we take the cosine inverse of negative 1/2, notice how it's not going to be negative 60. It's going to be positive another 60 over here, essentially. So this will be 150. I'm sorry, reference angle of 60 coming back. This will be 120. Now notice if you take the sine inverse of 1/2, you get power 6, you get 30. You take negative 1/2, you get negative 30. So there's symmetry here with respect to the origin. It's what's called odd. This is an odd function. So sine inverse of a positive is positive. Sine inverse of negative is negative. That's the difference. And now looking back at all of this, kind of coming back to tangent, if you will. Tangent is normal graph is like this, but if you flip it diagonal to where these become vertical asymptotes, now flip and become essentially horizontal asymptotes. The vertical now turn into horizontal. This thing kind of going upward kind of flips on itself diagonally. It goes this way. So where instead of going like this, it flips on itself. So it goes this way. So tan inverse cannot be bigger than 1/2. So like tan inverse of 1 is power 4. Tan inverse of 1,000,000 is close to 90, but it will never get there. So you can take tan inverse of huge numbers and tan inverse of small numbers. Now tan inverse of positives are positive, tan inverse of negatives are negative. Sine inverse of a negative is negative, sine inverse of a positive is positive. Tan inverse of negative is negative. Tan inverse of positive is positive. So tan inverse and sine inverse kind of work similar. Cosine inverse, however, of a negative is positive. Cosine inverse of a negative is a positive answer. Cosine inverse of a positive is also positive. So when you take cosine inverse of something, you're always going to get a positive answer. Cosine inverse of something, you're always going to get a positive answer. It's a positive in quadrant 2. If it's cosine inverse of negative, you're in the second quadrant, the angle between 90 and 180. If it's cosine positive, you're between 0 and 90. Tan inverse of negative, you're between negative 90 and 0. tan inverse of positive are between 0 and 90. Same thing for sine inverse. You can also use arc to represent inverse, so arc tangent, arc sine, arc cosine, and then from there, sine to the negative 1 power or arc sine mean the same thing essentially in our discussion. And the same thing for arc cosine and cosine inverse, and arc tangent and tan inverse. So here are a bunch of problems. So sine inverse of a half, what angle do you know has an opposite of 30? Sorry, opposite of 1, a hypotenuse of 2, that's 30. So sine inverse of a half is pi over 6. Sine inverse of negative half is negative pi over 6. So sine inverse of positive is positive. Sine inverse of negative is the negative of that answer. So arc sine or sine inverse of square root of 3 over 2 is 60 or pi over 3. Arc sine of negative square root of 3 over 2 is negative 60 or negative pi over 3. Arc sine of square root of 2 over 2 is 45 or pi over 4. Again, the answers have to be essentially in radians the way it's set up. And the arc sine of negative number is the negative angle. So negative goes to negative, positive. And positive goes to positive, negative goes to negative. Tan inverse, same thing. Tan inverse of 1 is 45. Tan inverse of negative 1 is negative 45. That's how this works. Tan inverse of square root of 3, again, opposite of square root of 3, adjacent of 1, the opposite of that will be 60. 60 has an opposite of square root of 3 and adjacent of 1. So arctan of negative square root of 3 is negative 60, or negative pi over 3. Cosine inverse of a half. What angle has an adjacent of 1 and a hypotenuse of 2? Adjacent of 1 would be, what, 60? And a hypotenuse of 2. But now cosine inverse of negative half is not negative 60. Notice that. It would be 60 degrees if it lived in the second quadrant, meaning what angle is in the second quadrant has a reference of 60? Well, that's 120. Arc cosine of square root of 3 over 2, adjacent of square root of 3, hypotenuse of 2, that's 30 degrees. But now, you see, arc cosine inverse of a positive is positive. Cosine inverse of positive is an angle between 0 and 90, so 30 degrees. Now, arc cosine or cosine inverse of a negative is not negative 30. It's an angle that lives in the second quadrant that has a reference of 30. Well, that's 150 or 5 pi over 6. And now you start looking at you take multiple values here, multiple trig functions together. So sine inverse of a half, remember, is 30 degrees. But sine of 30 itself is back to 1/2. So ultimately, when you take the trig function of a trig inverse function, these two things cancel. And so you have a half. So what cancels inverse trig? The original trig. What cancels trig? What cancels a cosine function? Cosine inverse. What cancels sine? Sine inverse. So it's very important to understand that what cancels any trig function when you want to get rid of it and get the angle itself, you take inverse trig. So tangent inverse cancels itself. So tan of tan inverse cancel and you have 1. Sine inverse and sine cancel, you get regular angle square of 3 pi over 4. Cosine inverse to cosine cancel, you get the angle 2 pi over 3. So every trig function is its inverse. Every trig function and its inverse cancel each other, and you get just the inside part. So that's what these next four are for. Original and inverse. The original and the inverse cancel each other. And then down here, these two. Now, what if they're not? What if it's not cosine and cosine inverse? What if it's not sine and sine inverse? Well, the idea here is you work your way inside out. Sine inverse of a half. Sine inverse of a half is pi over 6 or 30. So sine inverse of a half is 30, but now we want the cosine of 30. Cosine of 30 is ca. Adjacent of 30 is the square root of 3 and the hypotenuse is 2. So the square root of 3 over 2 is the answer to this problem. If you want the tan of cosine inverse of square root of 3 over 2, you want the cosine inverse of negative square root of 3 over 2. Now, you're back in this world. Cosine inverse of a negative is a positive angle that is in the second quadrant. Adjacent of square root of 3 and hypotenuse of 2 is essentially 30 degrees. So what angle lives in quadrant 2 that has a reference of 30? That's your 150. Now you want the tangent of 150. Now 150 lives in the second quadrant, and its reference angle is 30. So tangent of 30 is 1 over the square root of 3, or the square root of 3 over 3. But 150 lives in the second quadrant, so it's all students. S is positive there, so tangent is negative. So negative square root of 3 over 3. Real quick exercise, and I'm not going to do too much of this, because I'm not going to hold you to this, but just for your knowledge. Secant inverse, cotangent inverse, and cosecant inverse, they exist as well, but I'm not going to go through the graphs because it's not as important. What I'm going to show you is how to correlate those three to the three that we just did. So secant inverse of a number is the cosine inverse of its reciprocal, because cosine and secant are reciprocal. So if I want the secant inverse of a number, it's the same answer as if I took the reciprocal of secant and the reciprocal of the number. So it's like taking the reciprocal of both. So ultimately, the secant inverse of 2 over 1 is the same thing as cosine inverse of 1 over 2. Cosine inverse of 1 over 2, we've already done that. So it's pi over 3. Again, cosine inverse means what angle do you know has an adjacent of 1 and a hypotenuse of 2. That's when we'll go back to the 30, 45, 60 triangle. So these are going to be 30s, 45s, and 60s. That's what we're dealing with. Now, as you're dealing with this, cotangent of the square root of 3, cotangent inverse square root of 3 is a tan inverse of 1 over the square root of 3, which is a tan inverse of square root of 3 over 3. Now, to get that, you ask yourself, what angle do you know has an opposite of 1 and a adjacent of square root of 3? Well, that's 30 degrees. So cotan inverse of square root of 3 is pi over 6. Now, the next one is a cosecant inverse of 2 square root of 3 over 3. Now, remember, this, before we fixed it, was 2 over the square root of 3. And then it was fixed to look like that. This was the before picture. Before you rationalize it. So the cosecant inverse of 2 over the square root of 3 is the sine inverse of the reciprocal of this, or square root of 3 over 2. I think it's reciprocal. So the cosecant inverse of a value is the sine inverse of the reciprocal. Well, the sine inverse of square root of 3 over 2 is what angle do you know has an opposite of square root of 3 and hypotenuse of 2? Well, that's 60. And so that's how you get these answers. So to find secant inverse of a number, you look for the cosine inverse of its reciprocal. To find the inverse trig function, inverse cotangent, you look at tan inverses. And to find cotangent inverse, you take the tan inverse of the reciprocal of the thing inside. To find cosecant inverse of a number, you take the sine inverse of the reciprocal. And that puts us essentially through the end of 4.7.